Yeah, so I'm taking this opportunity to introduce Andrew to all of you. He's going to speak on the topic managing the test data nightmare. Okay, and to talk about his profile, he is the automation panda, an engineer, consultant, and an international speaker who builds solutions for software testing problems. He has designed and built robust test automation projects for operating systems, service APIs, web applications, I think mobile applications also. He is the lead developer for POA Constrictor, the .NET screenplay pattern, and currently he works as a full-time lead software engineer in test SDET at Precision Lender, a Q2 company. If you would like to get to know more about Andrew, please feel free to visit this particular link, which you are able to see on the screen. And then you can also get in touch with him on LinkedIn. So with this quick introduction, I would like to hand it over to Andrew, and please feel free to share your screen, Andrew, so that you can get started.
Sure. Hold on 1 second. What in the world? Looks like I have to. Hold on. I need to. Microsoft Teams is requiring me to change the security setting. Hold on. I'll be right back. Sorry.
Okay, no problem. Are you making use of a Mac machine? Seems to be.
Yeah, I think he's joining back, guys. Hang on there.
Yeah.
Especially for Mac users, Microsoft Teams sometimes asks for security settings.
Yeah. So meanwhile, I think Adi, you can quickly comment on how is the conference going so far. And
I think Andrew is back. Let him admit. I think it's going great. Dino session was amazing as well. Yeah.
Hey, sorry about that. Let me try this again. Let me share my screen.
Yeah, sure.
Ooh. Okay, there we go. Okay, sorry, folks. I know that was highly anticlimactic. Can everybody see my screen now?
I guess no. Not yet.
Okay. Yes, we can see your screen. Yeah.
Okay, so we should. One moment. Okay, yeah. Full screen slides. We should see managing the test data nightmare.
Yes.
Okay, thank goodness.
Yeah.
Cool. Oh, sorry, folks. So hello, everyone. Thanks for joining my talk. I'm really excited to be here as part of API Testing Summit 2021. My name is Andy Knight. I'm also the Automation Panda. I love building solutions to testing problems. So be sure to follow me on Twitter at Automation Panda. And here we go. Today I'm going to talk about test data, which is one of the toughest challenges in testing any software product. When I say test data, I'm referring to multiple things. It can include the actual data inside the product, as well as the values used by test cases. We shouldn't underestimate the work it takes to handle test data properly. Good data is just as important as good tests and good automation. So let's get to learning about it. Let's say we have an application for a bank to provide loans. The bank could configure this application for many different types of loans, such as a home mortgage, a car purchase, or even student loans. All the information the bank needs to provide loans must be stored as data in the system. Each product is different. It comes with its own rate, maturity, and payment schedule. The bank must also store information about borrowers, funding curves, and profitability targets for loan opportunities. It's fairly complicated, and testing requires that all data already be in the system as a prerequisite. So, we could write a simple test case to exercise the basic behavior like this. Scenario, create a new loan application. Given the Chrome browser is open and a page for my loan app is loaded, when the user creates a new loan application for home mortgage, and the user enters all their personal information, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. Now, bear in mind, a real loan application would probably need several pages of information, but let's keep our example simple. This test creates and submits a new home mortgage loan application for the user. There are many data points in just this short scenario. Most apparently, all the user's personal information is here. There's also the type of loan, the record of the loan application sent to the bank, the URL configuration information, and the browser type, which is a test input. Test data is everywhere in this short, simple scenario. The data is inextricable from the test. Without specific data, this test would be meaningless. Unfortunately, though, the term test data is ambiguous. We've applied it to both the product data in the loan web app, as well as the various pieces of test case data that make even the most basic tests work. Product data refers to real living data inside the software system. For the loan web app, product data includes all the bank's product configurations and lending information. Test case data, on the other hand, refers to data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve from the product. In the latter case, the test case data is a reflection of product data. Its values refer to entities existing in the product data. The two types of test data are separate but connected. Distinguishing these two types of test data is important to avoid confusion. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for home mortgages. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage application change? What if the loan is no longer called a home mortgage, but a personal residential loan? That would make the test case break. Compounding breakages cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code. How do we handle product data and test case data? Are there strategies we can use to avoid brittle dependencies? In this talk, we'll explore multiple ways to handle both product data and test case data. Unfortunately, there's no universal or perfect solutions to the test data problem, but you can avoid nightmares by picking strategies that work well for your needs. Let's start with product data. As stated previously, product data is any live data in the product or system under test. In simplest terms, it is everything in the database. Examples of product data include user accounts, administration settings, product customizations, records created by users, and even files uploaded by users. For our example loan app, product data would include user accounts, loan products, completed applications, and bank data. Data must be present in the product as a prerequisite for most testing. There are two primary ways to get that data into the system. On one hand, you can set up the data before running tests. This would be quote-unquote static data creation. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they're manual or automated, can presume that the static data is already in the system and simply reference it. Static data preparation is a good strategy for complicated data or data that is slow to create dynamically. For example, user accounts may need email verification, so it might be easier for automated tests to simply use a set of pre-registered users. Tests will run faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests. Static data may also become stale over time as data formats are updated or if data is time sensitive. On the other hand, you can set up data during test execution. This would be quote-unquote dynamic data creation. In the example loan test case, the loan application document is dynamically created. The test does not reference an existing loan application. It creates a new one. Dynamically created records avoid brittleness of hard-coded references of static data. They can also be used exclusively by the current test case, protecting them from interruptions by other test cases. The main downside of dynamic data prep is the execution time. It slows tests down. Dynamically created data is essentially disposable too, so it should be cleaned up eventually. Which strategy is best? Typically, testing requires both strategies together. Data that is slow to set up or considered immutable should use static preparation, while data that is quick and easy to set up should use dynamic preparation. When I develop test solutions, I prefer to create as much data as possible dynamically per test case to preserve test case independence. When a test creates the data it needs dynamically, it will be the only test using that data, and there is much lower risk of test collisions. These two data prep strategies are a bit complicated when implementing them. Dynamic prep depends directly upon the test case using it. However, static prep has a few general strategies that are independent of test cases. The simplest data prep strategy is manual configuration. That's exactly what it sounds like. Testers log into the system and manually create whatever records they need to be in the system. That could include creating users, configuring settings, and saving records. The nice thing about manual configuration is that it's low tech. Anyone can do it. It doesn't need fancy tools or complicated processes. However, manual configuration is slow. It does not scale well for large systems or large test environments. Furthermore, manually configured systems can easily fall into disrepair without any automated mechanisms for maintenance. A better strategy might be automated configuration. Rather than manually setting everything up, automated tools can create the desired data. This could be accomplished in many ways. Reusing UI interactions from tests, calling REST APIs, or even possibly using tools like Puppet or Chef. Automation could generate data deterministically or randomly. The main benefit of automation is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive fields. Unfortunately, automated configuration is not a free lunch. It requires extra skills, and code must be maintained. If you want a shortcut, you could try to clone the databases. Cloning databases is easier than ever with cloud management tools. You could maintain one database in a golden state and then create a copy before running tests. Once testing is complete, the copy could be deleted. Granular cleanup would not be necessary. Database clones make it easy to copy all data at once without worrying about any damage that rogue testing could cause. However, databases can have a lot of data, so cloning large ones may not be practical. Cloning may also need extra refinement to scrub special fields and hook them up properly. Finally, if managing real data is too much of a hassle, then you could mock endpoints. This would completely remove dependencies on databases and even services. All data returned by the mocks would be deterministic too, yielding consistent results. However, mocks are not always a good solution. They often require a lot of effort to set up, and mock data can make tests overlook unpredicted real-world variations. Mocks also mean that tests would not truly be end-to-end in coverage. These strategies can also work together. For example, you could use automated scripts to configure product data in a golden database And then you could make clones of that database. In another example, in a large test environment, you could choose to mock some of the endpoints while using real data for others. There are multiple factors that should be considered when deciding the best strategy for static data prep. First, how big is the data? If it's small, the manual configuration may be sufficient. If it's large, then automation may be required. How fresh does the data need to be? If data is time sensitive, then automation will be needed to keep it up to date. How frequently will the data need to be updated? Again, automation can help for frequent updates. How difficult will it be to try advanced tricks like mocking or cloning databases? This might be especially difficult for old legacy systems. Is there any bureaucracy in the way of automated solutions? Hey, it happens. Real talk here. Not every organization has an efficient or even a healthy culture. Bureaucracy can stonewall advanced solutions that need extra support. Do folks have the skills required for automation, database administration, or mocks? Skill level may be a barrier at first, but training and learning can help the team overcome any limitations here. And finally, what about the cost? Each data prep strategy has a cost. Teams should do a cost-benefit analysis when making their decisions. So, that's how to handle product data. What about test case data? Let's look at that next. Test case data is inherently part of test cases. Let's review our example test case from earlier. As we saw before, there are multiple bits of test data throughout the steps of this short scenario. They represent different types of test case data. First, let's look at the first step, given the Chrome browser is open. The Chrome browser is test data because it specifies the type of web browser in which to load the web app. Excuse me. This is what we call a test control input. It directs how tests will be run rather than specifying feature behavior. Theoretically, this test should run the same on any browser type, but the steps dictate that it should run on Chrome. As a best practice, test control inputs should not be hard-coded into test automation code. Instead, they should be passed into automation as inputs. That way, tests can easily be retargeted. There are a few ways to do this. The simplest way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they're easy to write, easy to read, and easy for programming languages to parse. They can also have line-by-line diffs. Test automation code can read the file before any tests start, and it can inject input values as appropriate. For example, using this JSON file, automation could read this browser type and construct Selenium WebDriver objects for Chrome for each test. The path for the input file would need to be hard-coded into the automation, but it would be as simple as a standard file name in the current directory. Another way to handle inputs is using environment variables. Tests could set variables from a system shell or profile, and automation could read those variables by name. They could be useful for integrations with continuous integration servers or Docker containers. However, it can be a little more dangerous because anyone could change variable values. Again, automation can read these variables before tests run and handle them appropriately. Let's remove that hard-coded step for browser type from this test scenario. That can be handled as an automation level concern. Next, let's look at a second type of test case data. Notice how the URL here is hard-coded. This is also not a good practice. Typically, development teams host multiple instances of products under development, like a development environment and a staging environment. Hard-coding configuration information like this limits where tests can run. Any information about a product's configuration is called configuration metadata. This can include things like URLs, usernames, passwords, and possibly other descriptors. There are a few ways to handle configuration metadata. You can use flat files or environment variables for like test control inputs. However, I recommend using flat files, and I also recommend separating the test control inputs from configuration metadata. Create an input to refer to the target configuration, and store multiple configurations in the configuration metadata files. That way, testers can change just a few simple inputs to target any configuration, and they won't need to change multiple configuration fields regularly. If you want to be fancy, you could create a web service to provide configuration metadata. That would be especially helpful for keeping secrets like passwords. However, creating such an endpoint may be overkill for your needs. Either way, the test step can be rewritten to refer more generically to the web app. Automation can select the target environment using the inputs and config metadata. The remaining pieces of test case data all fall into a category called test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. The first kind of test case value is a literal value. These are values that are hard-coded in the test. In this example, the table of personal info contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this info table will be entered as input values into the web app. Theoretically, these could be any values. The second kind of test case value is an output reference. These are values that are retrieved from the product under test. Typically, they are the outputs generated by exercising a behavior. In this example test, the reference number can be scraped from the success page and verified for correct format. The loan application can be retrieved from the web app's backend to verify that it was correctly submitted. These values cannot be literals because they originate from the product. Tests must refer to them by reference and retrieve their values from the product. As a side note, this test dynamically creates the loan application. This is an example of dynamic product preparation that we covered earlier. The third and final kind of test case value is the trickiest, the input reference. At first, these may look like literals. However, input references are values that directly refer to product data. While personal info like name and address are created dynamically by the test case, the name of the loan type refers to the loan configuration in the web app. Thus, this test has an input dependency. It must specify the type of loan, and the loan type must already exist in the product data. The simplest way to write this test is simply to hard-code the reference. That's what's done here. The name home mortgage refers to the name of the loan in the web app. Automation can use that name when selecting the loan type from a button or a dropdown. Hard-coded references make it easy to write tests, but they require statically prepped data to exist in the system already. References also become hard to maintain when the product data changes, or when the same test must be run against different configurations. One way to avoid this pain is to dynamically create these records or configurations. If the test calls the backend to create a new loan product named home mortgage, then static pre-prep isn't needed. However, we already know the pain points of dynamic prep. In this case, let's say dynamically creating a new loan type is too slow. A more robust solution would be data discovery. Let's say the target web app is already configured with multiple acceptable loan types. Instead of hard-coding the name and the desired loan type, the test could describe the loan using, the test could describe the loan and then use automation to search the web app's configuration to find a loan type matching the desired criteria. For example, if different regions of a bank have different names for this type of loan, the discovery mechanism could look into the configuration for a satisfactory home mortgage loan and return the specific name for the current bank's region. Discovery enables tests to search existing product data for required records instead of hard coding records. Discovery makes tests more resilient to changes in product data. It's great when testing multiple environments with ever so slightly different configurations. However, it does require extra code, and it may be overkill for small projects. So, that's a lot of information about test case data. In summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describes product configuration for the target environment. They should be supplied via config files or service API calls. Test case values direct behavior covered by tests. They may be literals, output references, or input references. And input references may be hard-coded or discovered. At this point, probably thinking, wow, that's a ton of information. That's it, right? We're done? We're ready for Q&A? Well, frightfully, the nightmare isn't over quite yet. There's one more problem to address: collisions. Collisions can happen wherever multiple actors operate on shared resources. For example, they could happen whenever multiple testers simultaneously access the system or when automated tests run in parallel. A few additional considerations must be taken to avoid collisions. First and foremost, isolate your test environments. Prevent external actors from interrupting tests. If you have a shared test environment, block other folks from accessing the system when tests are running. You might need to schedule tests during off hours. You might also want to set up multiple environments. If the product under test is already containerized, or if databases are clonable, then you could easily dynamically create fresh environments for each test launch. That would guarantee perfect isolation. Secondly, treat any shared data as immutable, meaning static or not changeable or constant. Sometimes shared product data is unavoidable. If tests run in parallel against one test environment, for example, then they may use the same product data. Or if an application has multiple components, certain components may be difficult to isolate for testing. Whenever data must be shared, treat that data as constant. Any changes to shared data could break tests. For example, if one test might require a car loan, but another test might delete the car loan type from the bank's configuration, then the first test will fail. Any test that must alter shared data should be run serially instead of in parallel, and they should always undo the changes they make. Third, and finally, use dynamic data preparation as much as possible. Tests cannot collide on data they don't share. Keep statically prep data to a minimum. Statically created data is more likely to become shared data, and shared data is more likely to cause collisions. Boom! There we have it. We've covered a lot of material in half an hour. Let's recap what we learned in brief. There are two types of test data: product data and test case data. Product data can be prepared statically or dynamically. Test cases can either control how tests run, test case data can either control how tests run or reflect product data. Handle references and shared data carefully. And overall, choose the best strategy to defeat your nightmares. Every product is different, and every team is different. Take the strategies I shared in this talk as suggestions. So thank you all so much for listening to my talk about test data today. Again, my name is Andy Knight. I'm the Automation Panda. Be sure to follow me on Twitter. Be sure to read my blog at automationpanda.com. Also, cool fun fact, I'm writing a book on software testing, so be sure to look out for that sometime next year. Thanks, and I hope you enjoy the rest of API Testing Summit 2021.
Thank you, Andrew, on time. And we are eagerly waiting to see your book.
Oh, thank you.
Yeah, thank you so much. It was another insightful session from you, Andrew. We do have some questions for you under the chat. I will be reading them for you. The first one is from Rudolph. He's saying, great talk, Andrew. The question goes like this. Sometimes you cannot use synthetic data and you need to have the data from production, which you must mask before using it as it is real-time data. So which tools you are making use of to mask the data from production? And the second question is which tools you are using to create the synthetic data?
Great questions. So in my current job, I'm actually not scrubbing data from production or generating data like that. I don't know any tools offhand that I can recommend. A lot of times what I've seen happen is if like either people will custom write scripts to do that scrubbing. Depending on your programming language, like in Python, you can use a library like Faker that's pretty good for just kind of putting dummy data values that are somewhat realistic. I'm sure other languages have similar tools. Another thing that you might consider is that if you're in a larger company, you might already have a data engineering team that's doing these kinds of things. So rather than doing it yourself, you might want to reach out to them and just say, hey, can I take a pipeline off of that data and kind of put it into my databases for testing? That could be a way to save yourself some time.
Yeah. Maybe, Andrew, I would like to ask you to switch on your webcam so that we can see you.
Webcam's not on? What?
It's on. Rituraj, we can see him.
Okay. I was about to say, I'm like, wait.
Maybe I'm unable to see him. Strange. Fine. No problem. Yeah. Okay, so there is one more question for you, Andrew. Test data creation is also a nightmare when we do performance testing. So any tips and tricks for performance testing?
I mean, I would say the test data preparation for functional testing and performance testing is pretty much going to be the same. The only considerations you might want to have for performance testing would be if you are trying to isolate or identify particular kinds of records, and usually like super large records, because the larger your objects are, the slower your performance is going to be. So you might want to kind of filter out the small objects and focus on the big objects depending on what you're trying to do. That would be the only nuance I would apply. Otherwise, I mean, it's the same, you know, same kind of strategy, same kind of use cases. Just like I said, you know, use your common sense, pick what you need for what you have at hand.
Yeah. Okay. Okay, so by looking at the time, I think we need to really wrap it up because we need to get back to track 1 to listen to our third keynote session and then towards the closure of this one-day conference. So this is the feedback URL which we have already shared. Please do submit your feedback, and I would like to take this opportunity to give a big thanks to Andrew. It was indeed a wonderful session. Simple, sweet, but then providing us lots of insights about test data. So thank you so much for being with us, Andrew. And yeah, thank you.